In this video, we're going to be looking at how to take multiple logs and go ahead and convert them into a single log. This is called condensing logs. Likewise, we're going to be taking a single log and then reversing the process to convert them into multiple logs, and that is called expanding. So with no further ado, let's do it. In order to understand how to both condense and also expand logs, you have to understand the three properties of logs. So over here we have a top one, a middle one, and a bottom one. And they look pretty complicated right now, to be honest with you. I wouldn't blame you if you looked at this and thought, wow, it's a lot to get. But I'm going to try to break it down for you right now. So on the top one here, what we have is, notice how they all have a b as their base. So for any of these properties to work, the bases must be the same. So in other words, b could be 10 here, but if it's 10 here, it has to be 10 in all the other ones too. If one of them is different, this won't work. But you'll see we have two logs with the same base with an addition in between them, and then it equals one of them. And this, what happens here is that if we take the m and the n, whatever's inside of there, we would multiply them together here. So I'm going to show you an example just with numbers of how this might work. So let's say we took log 4 and we also did log 7. And by the way, just so you know, on your calculator, if you just type in log, it's assumed to be base 10. So these are in base 10 if you don't put anything down. And you'll notice the answer is 1.447 and a bunch of numbers after that. So if this property to hold true, all we have to do is take 4 times 7. Well, 4 times 7 is 28. And I did my calculator again and found, wow, log 28 is the exact same answer. So that's kind of just using numbers, how this would work here. In the middle one, we have the same sort of thing here. All the bases have to be the same for this to work. We have a minus, though, in between our two logs on the left-hand side of the equation sign. And then we have division. So it'd be the first one divided by the second one. Once again, I came up with a little example here. So let's say we had log 18 minus log 3. The answer is 0.778 and a bunch of numbers after that. So if this were to hold true, what would happen is if we took 18 and we divided it by 3, well, 18 divided by 3 is 6. And wouldn't you know it, log 6 is the exact same answer here. So that's another illustration of how this works. Finally, this one has to do with powers. So here we have n times log base b of m. And then you'll notice here what happens is that power moves in to the actual log itself here. And you'll see we have m to the power of n. So here's an example using numbers of how that might look. So if we had 2 log 7, it would make sense that if we took that 2, moved it here as a power, 7 squared is 49, log 49, what do you notice? They're the exact same answers. As always, if you like what you see, please like, comment, or subscribe. Thank you, and back to part 2. Now that you know the 3 log properties, let's go ahead and use them here on condensing logs. So what's going to happen here is we have multiple logarithms, and we're going to basically combine them into one big happy log. So let's go ahead and do that right now. So I'm going to make a log. You'll notice in order for this to work, do they all have the same base? Yeah, they all have a 3. So I'm going to go ahead and put a 3 as my base here. And I'm going to go ahead and I am going to put a big fraction here, and I'll tell you why right now. Because there is a minus going on right over here, I'm going to have some things on the bottom of my fraction and some things on the top. That has to do with the quotient property from before. Anything that's a plus, which is the first and the third term here, that's going to go on top. So I'm going to have a 4 out in front, which makes it an exponent. So this will become a to the 4th. So I'm going to go ahead and write a to the 4th. And my other one that's a plus would be right here, that's a y. So I'm going to say times y. And then anything that's a minus is going to go on bottom. So because this is an x, that's going to go on bottom. So that's how you condense this one into one single log. Let's do the same thing on the second problem. I'm going to go log. For this to work, they all have to be the same base. Are they the same base? Yep, they're all base 5. So I'm going to go ahead and put a 5 right there. I'm going to go ahead right now and I'm going to make a fraction. Once again, why? Because I have some minuses right here. So let's deal with the things that are going to go on top first. So I have an r. So the r is going to go on top, and it'll be multiplied by the one that's last here, the 4th one. The 2 will become an exponent, so that'll become m squared. So I have m squared, so that's r times m squared. And then on the bottom will be both of these here multiplied together. I'm going to go ahead and I realize this is a little bit out of order, but that's okay. Notice I have a 7 here. I'm going to put that 7 out in front. And then I'm going to deal with this one here next. So I have a 1/2 as my power. So that'll end up being b to the 1/2. And b to the 1/2 is really the square root of b. So I'm going to go ahead and put the square root of b. So that's why I was kind of looking ahead there. I knew I was going to get the square root of b here. So I wanted to go ahead and put the number on front because that's what we do in math. We put the number and multiply by the square root. All right, so that's basically it. There's not really a whole lot going on here once you actually understand the rules of logarithms. So let's go ahead now and let's look at expanding them. So here we have one big logarithm. Now we're going to make it into lots of different things. So let's look at the top first. I have 5 times x to the third. So that times means I'm going to have two things together. So I'm going to write my 5 first. So log base 8 of 5. I'm going to go and put a plus because I'm multiplying right here. I'm going to move my exponent out in front. So I'm going to say 3, and then it's times log of x. And then anything that's on bottom, we're going to go ahead and we're going to put minuses before. So I have a 7, okay, so that will be, oh, I forgot to put the base right here of 8. So log base 8 of 7. And then minus, we have a y down here, so now I'm going to say log base 8 of y. So now we started the one logarithm, and now we're out to 4. Next up, let's take a look at this one. So I have 8 to the 4th on top, I have b to the 3rd, and c to the 5th on bottom. So we're going to go ahead. By the way, there is no base here. Do you notice that? So we don't have to write it, although it's an invisible 10. So I'm going to say 4 log a. Now, why did I write the 4? Well, that's because the 4 is an exponent, so I can write out in front and say 4 times log a. Anything on bottom, I'm going to put a minus before. So I have b to the 3rd, so that's going to become 3 log of b. And then we have c to the 5th, which will become minus, because it's on bottom, it'll be 5 log c. So that's it. That's how you expand, and that's also how you condense. Hope you liked the video. There is a part 3, so stay tuned, and you can go and take a look at that one too. Thank you.